Okay, next is the atomic number. So we already know that atomic number is the number of protons present inside the nucleus. Number of protons present inside the nucleus is called as atomic number. Is called as atomic number, and it is represented as Z, which is nothing but number of protons, which is also equal to number of electrons. So number of protons in an atom must be equal to number of electrons in an atom, so that atom is stable. Otherwise, it is not stable. Okay, mass number now. Mass number is represented as A. It is the total number of protons and neutrons present inside the nucleus. So if I have 10 protons, 10 neutrons, 10 plus 10 is equal to 20 is the mass number. So number of protons plus number of neutrons will give you the mass number. One nucleon is one proton plus one neutron. The combination of one proton and one neutron is called as one nucleon. Therefore, mass number is number of nucleons. So if you have 10 nucleons, then mass number is 10. So one nucleon is nothing but one proton and one neutron. So when you find A minus Z, A is the mass number, Z is the atomic number. So if you find A minus Z, you will get number of neutrons. This is the formula to find number of neutrons. A is the mass number. Mass number is nothing but number of protons plus number of neutrons, number of protons plus number of neutrons minus number of neutrons. So this neutron number will be cancelled. So this is minus number of protons, atomic number. So proton number will be cancelled. You will get the number of neutrons. So any chemical substance is represented, any nucleate is represented by formula X, Z, A. Z is the atomic number, A is the mass number, X is the chemical symbol of the element. For example, let us take chlorine, whose atomic number is 17, mass number is 35.5. Carbon, atomic number 6, mass number 12. Uranium 92, atomic number, mass number is 235. So nuclear size can be measured only by experiment. Experimental measurement showed that the volume of the nucleus is proportional to its mass number. According to the experiment, we found that volume of the nucleus is proportional to its mass number. Volume of the nuclei is proportional to its mass number. This is the experimental result we got. If R is the radius of the nuclei, you take a nuclei, if the radius of the nuclei is R, then its volume is given by 4 by 3 pi R cube proportional to A, which means 4 by 3 and pi are constant, which means R cube is proportional to A, because this 4 by 3 and pi are constants. So R cube is proportional to A, and R is proportional to A power 1 by 3. And R is equal to some constant A to the power of 1 by 3. This is the formula to find radius of a nucleus. This R0 is a constant and its value is 1.2 Fermi. What is Fermi? Fermi is 10 to the power of minus 15 meter, which means 1.2 into 10 to the power of minus 15 meter is 1 Fermi. 1 Fermi is 10 to the power of minus 15 meter. Therefore, instead of Fermi, I'm just substituting 10 to the power minus 15 meter. You will get 1.2 10 to the power of minus 15 meter. This is the value of R0. And note, see, mass number of different element is different. Since mass number of different element is different, radius of the nuclei of different element is also different. All the element will not have same nuclear size. Every element will have a nucleus, no? that nucleus will not be of same size. The size of that nuclei depends upon mass number. Since every element having different mass number, every element will be having different nuclei of different size. So nuclear size is not a constant. So nuclear density is generally mass by volume. It is defined as a ratio of mass by volume. Nuclear density is mass of the nucleus divided by volume of the nucleus. That is mass by volume. Volume of the nucleus. If suppose m is the mass of one nucleon. If m is the mass of one nucleon and A is the mass number means number of nucleons. A is the mass number, that is number of nucleons. Okay, so I have this much number of nucleons. So mass of this much number of nucleon will be this into this. This is mass of one nucleon. I have this much of nucleons. Therefore, mass of the nucleus is this into this. Mass of one nucleon into number of nucleons. Volume of the nucleus, what is the formula? Volume of the nucleus is 4 by 3 pi r cube. But we already know that r is r naught a power 1 by 3. Therefore, volume is 4 by 3 pi. If you take a cube of this, you will get cube of this into 3. 3 and 3 will be cancelled. So you will, instead of r cube, I can put r naught cube into a. So it is r naught cube into a instead of r cube. So 4 by 3 pi r naught cube into a. So now this 3 will go to the, I have to substitute this value in this formula. So density is equal to mass of the nucleus is Ma divided by volume of the nucleus is 4 by 3 pi r naught cube into a. Now we can cancel a from numerator and denominator. This 3 will go to the numerator. So rho is equal to 3 times m divided by 4 pi r naught cube. This is the formula to find the density of nucleus. Now let us substitute the values in this formula. 3 into mass of one nucleon is 1 atomic mass unit. Mass of one nucleon, the small m is approximately equal to 1 atomic mass unit. So 1.66 10 to the power of minus 27 is 1 AMU. So 3 times 1 AMU divided by 4 pi, 4 into 3.14 into what is R naught? R naught is 1.2 into 10 to the power of minus 15 meter, the whole cube. So when you calculate this, the density of nucleus will be 2.29 10 to the power of 17 kilogram per meter cube. So this is the density of nucleus, which is very, very high when compared to normal matters present in the normal state. Because for example, let us take water, density of water is 1000, but Here the density is 10 to the power of 17, which means nucleus is more denser than any other matter. So density, nucleus is almost in a compressed state. Pressure inside the nucleus is very, very high. Density is very, very dense. Nuclear density is very high. Okay, so this is much, much greater than normal material. So, and nuclear density is constant for all the nucleus. I told you in the previous session that size of the nucleus is not same for all the atoms, whereas the density is same. Density is constant. Size is not constant, but density of the nucleus is constant for all the nucleus. So what are isotopes? Isotopes are the atoms of the same element. For example, let us take hydrogen. Atoms of the same element. I take 3 hydrogens. All of them belongs to same element. Atoms of the same element having same atomic number but different mass numbers are called as isotopes. Atoms of the same element having same atomic number but different mass numbers are called as isotopes. Hydrogen has 3 isotopes, H11, H12, H13. H11 is called as protium or proton. In chemistry, they used to call it as protium. Then deuterium. This is tritium. These are all the isotopes of hydrogen. Since they have same atomic number, their chemical properties are similar. So chemical property depends upon atomic number. The chemical properties are similar, but physical properties are different. Physical property depends on mass number. So physical properties of isotopes are different, whereas chemical properties are similar. So what is atomic weight? See, hydrogen have 3 isotopes. They have different masses. So what is the mass of hydrogen? 1, 2, or 3? We don't know. So we have to find the average of all the 3 masses. That average mass is called as atomic weight. The average mass of an element is called as atomic weight of the isotope. The atomic weight of an element, is the weight of average of the masses of all its isotopes. Weight of average of the masses of all its isotopes. Isobars, atoms of different elements. For example, sodium and neon. Atoms of different elements having same mass number but different atomic numbers. Same mass number. Atoms of different elements having same mass number but different atomic numbers are called as isobars. They are called as isobars. Okay, then what are isotones? Atoms of different elements having same number of neutrons. For example, let us take chlorine. Isotope of chlorine 1737 and potassium 1933. The number of neutrons will be 37 minus 17 in this case, And in this case, it is 33 minus 19. So let us take H13 and He24. So in this, number of neutrons will be 3 minus 1, which is equal to 2. 4 minus 2, which is equal to 2. So atoms of different elements having same number of neutrons are called as isotones.